Hi everyone, welcome to the Unit 4.4 review video. Let's go ahead and get started. On number 1, we're subtracting two rational expressions, and we have a common denominator. Both bottoms match. So, what we do when we're adding or subtracting two rational expressions that have a common denominator is we go ahead and keep it. So, I'm going to go ahead and keep this as the denominator is 3x squared plus 27. And then across the top, the first top, or numerator, was negative 5x squared minus 5x minus 3. And we're subtracting from it 3x plus 5. I need to distribute the negative, so it ends up being negative 5x squared minus 5x minus 3 minus 3x minus 5 all over 3x squared plus 27. Now we're going to go ahead and combine like terms, and you end up with 3x squared plus 27 on the bottom still. And you have negative 5x squared. That's your only x squared term. And then our x's are negative 5x and negative 3x. So that gives me negative 8x. And then negative 3 minus 5 is negative 8. Okay, so we can go ahead and eliminate answer choices B and D because they do not match the answer that we got when subtracting those two rational expressions. Now we need to look at the second part of our answer choices. It asks us if the expression is undefined at x equals positive 3 and negative 3. What you need to think of is, do these values make the denominator 0 or make the bottom 0? If they do, then the expression is undefined there. If they do not make the denominator 0, then those values do not make it undefined, and they are good to go. So let's check. If we were to plug in 3 into 3x squared plus 27, it would give us a value that is not 0. Same with negative 3. So the expression that we came up with is defined at 3 and positive 3 and negative 3, so C is not our answer choice. And A is our answer choice because it says the expression is always defined. Well, no matter what value I plug in for x in my denominator, it will give you a value other than 0. So A is our answer choice for number 1. All right, let's move on to number 2. Okay, on number 2, we're adding two rational expressions, and when we are adding or subtracting, remember the first thing that we have to do is find a common denominator. Well, here in the first rational expression I have the denominator is x minus 7. In the second one, we have x squared minus 5x minus 14. I noticed that I can go ahead and factor my second denominator, so I rewrite this as x plus 5 over x minus 7 plus negative 13x minus 17 over, I can factor the x squared minus 5x minus 14 by thinking of two numbers that add or multiply to negative 14 but add to negative 5. So that's going to be negative 7 and positive 2. Okay, now what I do to find my common denominator is I always go ahead and look at my terms. Well, I have an x minus 7, I have another x minus 7, and then I have an x plus 2. Well, I never write a factor more than once. So my common denominator, I write the green. I have two greens, but I only write it once. X minus 7, and then I write x plus 2. So that is my common denominator. Okay, next I need to look at, well, which one was missing? What? Well, the first rational expression, the x plus 5 over x minus 7, is missing x plus 2 in the denominator. Well, if I put that in the denominator, I also have to put it in the top. So what I'm going to do now, my new numerator in the first rational expression is x plus 2 times x minus 5. So I go ahead and write that all down. X plus 2 times x plus 5. And then I keep the plus negative 13, so technically that's minus 13x minus 17. Okay, now I need to go ahead and multiply the x plus 2 and the x plus 5. And that you can do by FOIL. So when I multiply my first two terms together, the x and the x, I get x squared. The outside two terms give me 5x, and the inside terms give me 2x. So when you add those together, it becomes 7x. And then when I multiply my last two terms, 2 and 5, I get 10. So I just FOILed that out, and then I bring down the negative 13x minus 17. And remember, that is still all over our common denominator of x minus 7 times x plus 2. All I do now is combine like terms. I have my x squared terms, my x terms, and then my constants. And let's go ahead. Oop, I don't like that color. And combine them. So I have x squared minus 6x minus 7 all over x minus 7 times x plus 2. Now I have to think. I look at my answers and I realize that none of those answer choices aren't there yet. So I have to keep going. There's still something else I need to do. I have to factor out my numerator. So I think of two numbers that multiply to negative 7 but add to negative 6, and that is negative 7 and positive 1 all over x minus 7 times x plus 2. I realize that I have an x minus 7 on top and on the bottom, so I can go ahead and scratch those out. And all I'm left with is x plus 1 over x plus 2. And A is going to be my answer choice. That is the answer choice that is given. Okay, let's move on to number 3. Okay, so in number 3, we're subtracting two rational expressions, and I need to find a common denominator. Well, when I don't have a common denominator that is obvious, I need to factor my denominators out. And when you factor the first term, it becomes x plus 3 times x minus 3. And by term, I meant denominator. Sorry about that. So I factored out my denominator of the first rational expression, x squared minus 9. And I recognize that I can factor it out because it's a difference of perfect squares. So it becomes x plus 3 times x minus 3. I keep my numerator for now as 2x squared minus 36. And then the other denominator is not factorable. So I leave it as x plus 3. Now remember, I look across and I go across my denominators. I have an x plus 3, I have an x minus 3, and then I have another x plus 3. I never repeat anything. So I'm going to write the x plus 3, I'm going to write the x minus 3, but then I do not write x plus 3 again. Then I need to look at which side was missing what. Well, the second rational expression that I'm subtracting was missing an x minus 3 in the denominator. So I multiply the top and the bottom by x minus 3. So what am I left with? On the top, I'm left with 2x squared minus 36 minus x plus 6 times x minus 3. Okay, so let's keep going. We're going to go ahead and FOIL what we just multiplied together. So we have x plus 3 times x minus 3 still on the bottom. And on the top, I'm left with 2x squared minus 36 minus, when I FOIL these out, I end up with x squared, because that's my first two terms. And then when I multiply my outside two terms, I end up with a negative 3x. And then my inside two terms is a positive 6x. When I combine those, I get a positive 3x. And then I multiply my last two terms together, and that's negative 18. Okay, so now we have to distribute this negative. And when we do that, we end up with, we're still left with x plus 3 times x minus 3 on the bottom. And we end up with 2x squared minus 36 minus x squared minus 3x plus 18. I combine my like terms, my x squareds, my numbers, my constants, and my x's. Okay, so I end up with, on the top, just x squared minus 3x minus 18 all over x plus 3 times x minus 3. When I look back up at my answer choices, none of those are there. So I need to continue trying to factor out things, and I need to factor my numerator. And when I factor out x squared minus 3x minus 18, I have to think of two numbers that multiply to negative 18 but add to negative 3. And those numbers are negative 6 and positive 3. And remember, we keep it over x plus 3 and x minus 3. I can scratch out the x plus 3's because those cancel out, and I'm left with x minus 6 over x minus 3. And when I look back up at my answer choices, D is the only option with that answer choice. And I want to make sure and point out that D also says that the expression is undefined at 3 and negative 3. And if you notice, that is because if you look at the completely factored common denominator of x plus 3 times x minus 3, the values of x that would make that common denominator 0 are negative 3 and positive 3. All right, let's move on to number 4. Number 4 is asking us to simplify the following expression. So we're multiplying here, and we need to simplify, and the best way to do that is I look at my numbers first. So let's look at my numbers, or the coefficients, you could say, 3, 5, 54, and 37. I need to look at the numbers on the top and the bottom and see which ones I can cancel out, if there's anything I can reduce. And I can recognize that 3 goes into 54 18 times. So I can reduce that down to 1 and 18. Now I'm going to go ahead and multiply my numbers. So let's multiply those blue numbers. And I'm left with 37 on the top. And on the bottom, I'm left with 5 times 18, which is 90. Okay, so now we've taken care of our numbers. Now let's look at our p's. I have a p to the 4th on the top, and I have a p to the 3rd on the bottom. The way I look at it is I see I have 4 p's on top and 3 p's on bottom, so the top wins, and the top wins by 1. So the p stays on top with a power of, or exponent of 1. Okay, now let's look at my q's. I have a q squared, and I have a q to the 5th on the bottom, and I realize that there are 5 q's on the bottom and 2 q's on the top, so the bottom wins, and it has 3 more than the top does, so we write it as q to the 3rd on the bottom. Now we need to look at r minus 5. And I have an r minus 5. I'm going to go ahead and try to find another calculator or highlighter color. Okay, so r minus 5 on the top is 1 r minus 5, and on the bottom I have 3 r minus 5. So the bottom wins out, and it wins out by 2. So I put r minus 5 on the bottom, and there are 2 extra on the bottom than there were on the top. I look at my answer choices, and answer choice D is the correct answer. So that is the answer to number 4, and that's what we found. Okay, moving on to number 5. Okay, number 5 is asking us to simplify the following expression that we're multiplying, and the way I do it, like I said, I look at my numbers first. So I look at 40, 80, 31, and 2, and I realize that I can reduce the 40 and the 80. So I'm going to scratch out 40, and I'm going to scratch out 80, and that reduces down to 1, and 80 becomes 2. Okay, so I multiply my top. I have 31 number-wise left on the top. And on the bottom, I have 2 times 2, which is 4. Okay, now I'm going to look at my x's. So I have 1 x on the top and 3 x's on the bottom. So the bottom wins out by 2. There are 2 more x's on the bottom than there are the top, so we write it as x squared. Then I go ahead and look at my y's. I have 2 y's on the top and 1 y on the bottom. So the y's on the top went out by 1. So we write y to the 1st power on top. And the answer choice that matches what we just came up with is D. So the answer to number 5 is D. Moving on to number 6. Okay, on number 6, we are dividing 2 rational expressions. And what you can realize is that whenever you see a division sign, we never divide when we have fractions. I believe the saying goes, when dividing by a fraction, don't be shy, flip the second and multiply. So we're going to change this into a multiplication problem, but before we do that, we have to flip the second fraction that we see. So I write this as 5x squared y to the third over 3a to the fifth b to the fourth times, I flip the second, 2a to the seventh b to the third over 31 x to the fifth y. And now it's similar to problems 4 and 5 where we're just going to simplify. And I always look at my numbers first. So I look at my 5, my 12, my 31, and my 3. And I need to see which ones I can reduce. Well, I can simplify 3 and 12, and those reduce down to 1 and 4. So my numbers, when I multiply across the top, I multiply the 5 and the 4, and I'm left with 20. And then when I multiply across the bottom, I am left with a 31. Now I look at my x values. I have an x squared on the top and an x to the fifth on the bottom. Well, we have 5 on the bottom and 2 on the top, so there's more on the bottom, and there are 3 extras. So bottom wins out by 3, so I write x to the third. Then I look at my y's. I have a y to the third on the top and just a y on the bottom. And we know that those cancel out, or we can divide those. Y cubed divided by y is y squared. In other words, the y has 3 on the top and 1 on the bottom. Top wins out by 2. Okay, now we need to look at our a and b. I have 7 a's on the top and I have 5 a's on the bottom. So the top wins out by 2. So we write a to the second power on the top. And when I do my b's, I have a b to the fourth on the bottom and a b to the third on the top. The bottom wins out by 1, so 4 b's on the bottom beats out 3 b's on the top. So we write it as b to the first on the bottom. And I look over at my answer choices, and it looks like my answer choice matches answer choice D. So answer to number 6 is D. All right, number 7, moving on. Okay, here we're dividing two rational expressions, and remember, when you're dividing by a fraction, don't be shy, flip the second, and multiply. So I'm going to rewrite this problem as 5 times a squared plus 5a plus 6 over 3 times a squared minus 64. And we're going to flip the second and multiply, so the second rational expression becomes 51 times a plus 8 over 31 times a plus 3. Now I need to make sure that I factor out the top and the bottom. So I'm going to factor out the top to be 5 times a plus, I need two numbers that multiply to 6 but add to 5. And that's 3 and 2, and they can both be positive. So positive 3 and positive 2. And then when I factor out the bottom, I realize I have a difference of perfect squares. So this becomes a plus 8 times a minus 8. And we're multiplying it by 51 times a plus 8 over 31 times a plus 3. Okay? Well, I realize that I have an a plus 3 on the top and an a plus 3 on the bottom. And then I have an a plus 8 on the bottom and an a plus 8 on the top. So I can go ahead and scratch those out. Okay, and then I can also now look at my numbers and realize that I can reduce the 3 and the 51 to be 1 and 17. So now I can go ahead and just multiply across in the bottom. Multiply across the top and the bottom. So I multiply 5 times 17, and that gives me 85. And I'm left with 85 times a plus 2 on the top. And then I'm left with 31 times a minus 8 on the bottom. So the answer to number 7 is answer choice B. Okay, let's move on to problem 8. In problem 8, we have a fraction being divided by another fraction, so we could always rewrite this problem to where we're used to seeing it as d over 37 f squares with the division sign in between, divided by d to the 4th over 32f cubed. Now remember, if you're dividing by a fraction, don't be shy, flip the second and multiply. So it's d over 37f squared times, we're going to multiply now and flip the second. So it's going to be 32f cubed over d to the 4th. So remember, you look at the numbers first, now that we're multiplying, 32 and 37. And I realize that I can't reduce those really, so I'm just go ahead and bring down 32 over 37. Then I'm going to look at my d's. I have 1 d on the top and 4 d's on the bottom. So I have 3 extra d's on the bottom. The bottom wins out by 3. So we write it as d cubed. And then I have 3 f's on top and 2 f's on bottom. So the top wins out by 1. So we write it an f to the first power on top in the numerator. So my answer is 32f divided by 37d cubed. And that is answer choice number B. So the answer choice to the answer to number A is B. Let's move on to problem 9. Almost done. Okay, so on problem number 9, we do not have a common denominator. We're subtracting 2 rational expressions. So I need to go ahead and factor my second common denominator. So our second denominator. So I'm going to rewrite this as 8 over y plus 2 minus 7y over y plus 2 times y minus 2. Can you think of where I got the y plus 2 over and times the y minus 2? Well, I noticed that y squared minus 4 was a difference of perfect squares, so that led me to factor it that way. And remember, once again, I go across to find my common denominator, but I don't repeat anything. So my common denominator I know is going to be y plus 2 times y minus 2. Okay, and then I realized that the first rational expression is missing a y minus 2 in the denominator. So I have to put that there. Well, I also have to put it in the top. So I write my numerator as 8 times y minus 2 minus 7y. I distribute the 8, and I end up with 8y minus 16 minus 7y all over y plus 2 times y minus 2. Okay, combine like terms. 8y and 7y on the top become 8y and negative 7y becomes just y. So I have y minus 16 over y plus 2 times y minus 2. Okay, so the answer choice that looks like that is answer choice B. So my answer choice number 9 is B. Let's move on to number 10, our last problem. On number 10, they ask us to simplify and identify any values for x, which the expression is undefined. So I'm going to go ahead and factor the top and the bottom. Well, in the top, I have a negative in front of my x squared. So I pull a negative out of my numerator. So I'm left with x squared plus x minus 6. And then on the bottom, I can factor out x squared plus 6x minus 6. Because two numbers that multiply to negative 16 but add to 6 are 8 and negative 2. So x plus 8 times x minus 2. And then I try and factor out the top, and I end up with negative times x. And I have to think of two numbers that multiply to negative 6 but add to 1, and that's positive 3 and negative 2. So I have negative times x plus 3 times x minus 2 over x plus 8 times x minus 2. I go ahead and scratch out my x minus 2's, and I'm left with negative times x plus 3 over x plus 8. I distribute the negative, and I'm left with negative x minus 3 over x plus 8. Okay, and I can go through and eliminate A and C as my answer choices, and I'm left to figure out whether the expression is undefined at just x equals negative 8, that's answer choice B, or if the expression is undefined at 2 and negative 8. Well, don't let B trick you. they will, a lot of people will put answer choice B, but remember, I told you, you have to look at the completely factored form of the denominator to see which values make that 0. Don't just look at your simplified version. You have to look at the completely factored common denominator. And if you plugged in -8 or +2, those would give you an undefined expression because that would make your common denominator 0. So my answer choice to problem 10 is D. Okay, I hope this helps. Come let me know if you have any questions in the morning at 6:45. And good luck on y'all's test tomorrow. Have a good one.